Hello viewers, welcome to my channel. Today we shall be looking at the topic Pythagoras theorem. Pythagoras theorem is an aspect of trigonometry that has to do with right-angled triangle. As you can see on the board, this is a perfect description of right-angled triangle. Why do we call it right-angled triangle? Because it contains the right angle. Right angle is 90 degrees. This is perfect description of it here. And because of this, the presence of this right angle here, we call it the right-angled triangle. All right, so in the right-angled triangle, the sides are described as follows. The side that is facing the right angle, the opposite of the right angle, is known as the hypotenuse. Sometimes some students do call it the longest side of the right-angled triangle. But you have to take note of this, that it is the side that is facing the right angle. That is exactly the one you call the hypotenuse side. Then these other sides are being described as the opposite and adjacent, depending on where the angle exists. If the angle exists here, that is to say A is opposing the angle here. So in that case, A becomes the opposite, while B becomes the adjacent. But if the angle is introduced here, of course, the angle will now be facing B. In that situation, B becomes the opposite, while A becomes what? Adjacent. So it depends on the position of an angle inside. But we shall be looking at that in our subsequent video, where we'll be talking about the SOHCAHTOA and also digress some other aspects of trigonometry, trigonometric ratios, and some other things that are associated with it. So now let's look at Pythagoras theorem. This is a situation whereby you have two sides given in a right-angle triangle and you are asked to find an unknown side. Take for example, A and B is given as figures and you're asked to find C. Then you have to consult the Pythagoras theorem. The theorem states that the square of the hypotenuse side is equal to the sum of the square of the other two sides. And what are the other two sides we're talking about? That's A and B. The hypotenuse side represents C. All right, so how do we now represent this mathematically? Let's follow the theorem. The theorem says the square of the hypotenuse side here is C. So the square of the hypotenuse side, C, is equal to the sum of the squares of the other two sides. That will now be A squared plus B squared. This is exactly what the theorem is talking about. That the square of the hypotenuse side, which we label as C, is equal to the sum of the squares of the other two sides. That is A squared plus B squares. A situation whereby you are being given B and C and you are asked to find A. The formula will look like this. You make this subject of the formula, make A subject of the formula. That gives us A squared is equal to C squared minus B squared. And another situation whereby you are being given A and C and you are asked to find B. So the formula will look like this. That will be B squared is equal to C squared minus A squared. This is exactly how the formula looks on how to find the various sides of the right-angled triangle using Pythagoras theorem. Now let's take some examples. Here we have example on the board. Example 1, whereby we have right-angled triangle and we have the side 4, we have the side 3, and an unknown side to be found. Now let's describe this. What does X represent? X represents the hypotenuse because that is the side that faces the right angle. So we call it the hypotenuse. Remember what the theorem states, that the square of the hypotenuse side is equal to the sum of the squares of the other two sides. Let's apply it in this example and see what we are going to have. All right, so here is the hypotenuse. The square of the hypotenuse side, which is X squared, is equal to the sum of the squares of the other sides. That will be 4 squared plus 3 squared. So what do we have? X squared is equal to 4 squared gives us 16. That is 4 times 4 plus 3 squared gives us 9. That means 3 multiplied 3. So we now went further to have X squared equal to this plus this. That's 16 plus 9 will give us 25. So the next step we take is to take the square root of both sides. So when you take the square root of both sides, then that becomes the square root of 25. And the square root of 25 is, of course, equal to 5. And that is the solution to this question. Now let's take some other examples. Here is another example. Example 2. The question says find the value of y. As you can see from the diagram, we have the side 5, 13, and y. Y is the unknown side that we have to find. All right, so how do we approach this one? We have to consult our rule, which is called Pythagoras theorem. All right, so the hypotenuse side, as far as this one is concerned, we can guess the hypotenuse side. Of course, the hypotenuse side is 13, but that is the side facing the right angle. So we have to follow the Pythagoras theorem, which says that the square of the hypotenuse side, in this case, the hypotenuse side is 13 squared, is equal to the sum of the squares of the other two sides. And the other two sides are y and 5. 5 squared. All right, so what do we have here? That will give us 169 is equal to y squared, because that is 13 multiplied by 13 will give us 169, plus 5 multiplied by 5 will give us 25. So what do we do next? We collect like terms. That is to say, plus 25 moving to the other side become minus 25. That's what we now have as 169 minus 25 is equal to y squared. So what do we do next? That becomes y squared is equal to 169 minus 25 will give us 144. Then you take the square root of both sides. That gives us y is equal to square root of 144. Of course, the answer will be 12. So 12 is the answer to the question. That is to say, y represents 12. In that instance, 5, 12, and 13 are referred to as the Pythagorean triple. Pythagorean triple. Take note of that. The first one we solved, we got the answer of the three sides to be 3, 4, 5. That is to say, 3, 4, 5 are known as the Pythagorean triple. All right, so let's take another example. Here is another example. You can pause the video and give it a try. Pause the video and give it a try. So the solution goes this way. We have to always consult Pythagoras theorem whenever we are being presented with this kind of case. All right, so the square of the hypotenuse side, that is m squared, is equal to the sum of the squares of the other two sides. That gives us 24 squared plus 7 squared. M squared is equal to 24 squared will give us 576 plus 7 squared will give us 49. M squared is equal to 576 plus 49 will give us 625. So what we do next? We take the square root of both sides. M is equal to square root of 625. Of course, the answer will be 25. So therefore, 7, 24, 25 is known as the Pythagorean triple. Let's take yet another example. Now here is the example 4. I will leave you to solve this one and leave your answer in the comment section. Let's see who gets the answer first. Have a nice day. I believe this video is very interesting. Please don't forget to click on the subscribe button. In our next video, we'll be talking about the SOHCAHTOA, what it has to do with angles inside the right angled triangle, where we'll be talking about the trigonometric ratios of right angled triangle. So from there, we'll be able to solve so many other aspects of trigonometry that will be of great interest to you. Do have a lovely day ahead. Bye.